Hello, today I thought I would like to share something interesting I just found out. I've been just starting a new project and I want to use these reduced motors that I could find very cheap. It's kind of a robotic project, so I want to measure how much the motor is moved. And to do that I thought I got these light sensors that were also not very expensive, so I got a whole bunch of these. These have an infrared LED inside and a light activated transistor on the other side, and when something passes through the cut, it blocks the light and this sends a signal. So for example, if we have a wheel, we could measure a wheel with holes, we could measure how many holes have been passing through this. So this is exactly what I've done with one of the first prototypes. So I've 3D printed a wheel, as you can see here, with these tiny slits through which the light can pass, and most is blocked, and as this wheel rotates, it should send different signals via the sensor, and I should be able to count how many times a hole has been passed and then how many degrees the wheel have turned. So I 3D printed this bracket for holding the sensor. It can be put like this, so everything fits nicely together, and as you can see, the sensor is really looking at the slits and the holes. So the sensor has 4 cables. We need to power the LED, of course, and this is so as you can see, the circuit I've made here is very simple. I just power it via a 5-volt power supply, and these 2 cables power the LEDs, so a negative and then a positive connected via 100 ohm resistor to limit the current through the LED. And then the transistor, I think I connected it with the emitter to the ground and the collector to the positive via a 10 kilo ohm resistor, and I tried a few different values and this gave the highest gain. So if we measure the voltage here, when there is a hole and light is passing through, the transistor is letting current through, so this there will be a current through this resistor, and this side will be almost at 0 volts. Otherwise, when there is no light, the transistor behaves as an open circuit, so no current passes through this resistor, and the voltage we read should be approximately 5 volts minus whatever current we need to measure the voltage, but it will be much higher than when there is a hole. Okay, so because these things will be moving, I thought we can measure the change in voltage here with an oscilloscope, because that would be the easiest way to visualize what's going on. So connect the ground of the oscilloscope to the ground here, and then we connect the probe to this pin, which is where the voltage should change. And then of course we need to power the motor, and for that I have a second power supply, should be here, yes. Opa. Okay, so hopefully you can see what's going on. So this might not look too bad at first, but the problem is the voltage was not swinging as much as it should. Now, for example, if we just take the sensor out, and now this is 0, it's corresponding to the lower line, and see what happens if I just use a piece of paper and I put it in front of the sensor. The voltage goes completely up to here, and I haven't changed any settings, so this is really like registering 5 volts. We have 0.1 volts per division. We went up like 1, 2, 3, 4.5 divisions, and the probe is set to extend, so it's reducing the voltage by 10 times, so that comes out to 4.5 volts, so basically 5 volts. And this is where the issues begin, because how come this wheel is much thicker than this sheet of paper, and it's definitely opaque? So what's going on here? And my first thought was, oh, maybe I made the holes too large. So if you look, this was the first wheel I printed, and the holes are indeed, I thought I make the holes just as large as the fulls, because then the signal is more symmetric. And then I saw an even worse signal than what you saw there, and what I thought was happening is, so maybe the light, this is not fully blocking the light, and even when there is this in front of the sensor, the light is still coming from the holes to the two sides. And so I made this, which has a much thinner holes, and in theory this one, it should be impossible for the light to pass through the hole even when there is no hole in front of the sensor. However, as you saw, the signal it becomes wider, but it's still very hilly as well. Like, why is it not just pam pam pam, right? And at this point I was running out of options, and with the paper it was working so well, so I thought maybe the problem is in the material. And indeed, it seems this plastic is transparent to infrared. So I had this thing laying around that I printed for something else, but this is a very thin piece of 3D printed plastic, but it doesn't have holes here, and yet when I do this, look, no change at all. It's completely transparent. Of course, this is much thinner. It is almost as thin as the piece of paper, but you see that there is definitely a problem with the plastic. And then I was thinking, is PLA, so this is the plastic I'm 3D printing, is PLA completely transparent to infrared? I don't know, but I was playing around, so I found this piece from a failed print. This is a natural PLA, so it doesn't have any colorant, and it's even somewhat transparent to visible light, and this is quite thick, I think around 2-3 millimeters. And when I put this in, you see the change is a bit less than with this very thin red wheel. So okay, at least we figure out something, that at least the red wheel seems to do better than the transparent PLA. So definitely, I guess natural PLA is quite transparent both to visible and to infrared light, which was quite a surprise to me, but okay. So, and then what do I do? Should I paint the wheel with something that's not transparent to infrared? That would be one extra step. So of course, the first thing I wanted to try is, maybe black PLA is not transparent. And indeed, you see, this is unfortunately this piece is not uniform in thickness, but this end is quite thin. But you see the black PLA already performs a lot better than the transparent one, and it seems to be performing better than the red one too. And then I tried something else, so I had also this piece laying around. This is white PLA, and this is just half a millimeter thicker than the wheel. So the wheel is 1 millimeter and this is 1.5 millimeter thick. So we could compare. And already you see here the signal jumps up and down, almost the complete range. It's not as good as the paper, so it doesn't quite reach, I think. Yeah, it doesn't quite reach the top line, but this I would be happy with. And this is actually simple to fix. I could just print this wheel in another color, so that's what I'm doing now. Alright, by the magic of printing it, I have now a white wheel, and I've also made it 1.5 millimeter thick, so same thickness as this piece, which was working well. Also, since the size of the hole didn't seem to be a problem, I kept the hole thin, but I made the full as thin as the holes, so I increased the number of holes, which gives a higher resolution basically in the measurement. So now instead of having around 20 divisions, so I know like a 20th of a turn, now I have 30, so I have like 1.5 times the resolution. So let's replace the wheel. Alright, let's see. Haha, already this is a good sign. So by randomly placing the wheel, I placed it over a full section, and you see just by wiggling it a bit I can make it go from the full to the hole, and the signal is changing is swinging by almost the full range. So yeah, it's actually performing better than this. It's very close to 5 volts of swing, or 4.5. Anyways, let's try, see what happens when it turns. Oh, wonderful. Yes, this is looking really good. I hope this can be seen on camera. Seems also much more regular, like the trigger is much more capable to reproducibly show the same curve. It's just a garbled mess. Increase the intensity a little bit. So yeah, even at high frequency, it's swinging from. It's actually swinging. No, yeah, like around 4.5 volts. So yeah, 4.5 divisions. 1, 2, 3, 4.5. That's 4.5 volts. Okay, wonderful. So hopefully soon enough I'll connect this to Arduino or whatever, so it can stop the motor once it's seen enough pulses and it knows the position of the motor. Alright.